All right, in example 2.2.7, we have a linear map from polynomials of degree 2 to polynomials of degree 2. It's going to send a0 plus a1x plus a2x squared to 3a0 plus a1x plus a0 plus a1x squared. All right, first question, I want to find a basis for the kernel, and I want to know if the map is one-to-one. All right, so I'm going to assume that I have a polynomial that is sent to 0. All right, so this is 3a0 plus a1x plus a0 plus a1x squared. I'm going to assume that it's 0. All right, so that means all of the coefficients need to be 0. So 3a0 is 0, a1 is 0, and a0 plus a1 is 0. If you solve for this quickly, you get that a0 is 0, a1 is 0, and you think, oh, well, that's good. That means I only have 0, but wait, we had another variable. So if you put it in a system, you'll get 3, 0, 0, 0. You'll get 0, 1, 0, 0, and 1, 1, 0, 0. I'm going to get a free variable. When I reduce it, I'm still going to get a free variable, and so that means a2 is S. All right, so that means the kernel of T is going to be the set of Sx2, S, and R. All right, so your basis is just, the basis for the kernel is just x squared. We have a basis. That was the first question. Second question, is it one-to-one? Well, no, this isn't 0. And so we don't have a one-to-one map. Good. It's kind of nice because to prove something is one-to-one, we only need to check one potential value for y. We only check 0, and it gives us the answer for everything else because then the map is nice and linear, which is good. All right, find a basis for the image of t. Is it onto? All right, so let's see what p of x looks like. We have 3a0 plus a1x plus a0 plus a1x squared. Actually, that's t of p, right? And I can write this. A0 multiplies 3 plus x squared, and a1 multiplies x plus x squared. And so the image of t, and this is a0, a1 in R. So the image of t is actually the span of these two polynomials. I want it to be a basis, so I need to check that it's linearly independent. So I need to check it's linearly independent. I'm going to assume, let's call it A1, 3, actually I already had A1, let's do A and B, x squared plus bx plus x squared equals 0. I get 3a plus bx plus a plus b x squared equals 0. That means 3a is 0, b is 0, a plus b is 0, and so a equals b equals 0. So yes, it is linearly independent. All right, so our basis for the image is 3 plus x squared, x plus x squared. Right? First question answered. Now from this, can we tell if t is onto? Well, t is onto if the image is P2, but I only have 2 generators and P2 has dimension 3, so I can't hit everything. So the rank of T is 2, which is less than the dimension of P2, which is 3. All right,